Hey guys, we are Team SuperFit. My name is Wenya, and this is Jiaxin. We are the programmers of this team. And we are also students from ECE department, majoring in computer engineering.
And my name is Shu. I'm the specialist for this course. I'm doing my Master of Engineering Electronics, but I also have my area of expertise in personal training where I'm looking to get certified by CPT as a personal trainer. So as you might know, there are millions of people who go to gym and work out in order to improve their overall health being. However, there are two major problems. One being that the weight that they lift may be too heavy. As a result, they can easily injure themselves. And second being that they might not know number of repetitions or number of sets for each exercise, and particularly for their goal. So that brings to the goal of our app, and that is to choose the exercise weight for the user such that the weight they use will be very safe and effective. And at the same time, we can recommend a number of sets and repetitions for every exercise that they perform. To see how this works, basically, research study shows that we can compute 50% RAM maximum as a function of users' heart rate and age. And what percent RAM maximum is, it is basically like a measurement, weight measurement, as intensity for the user to perform particular exercise with given number of repetitions. For example, 100% RAM max would indicate the user has to exert all of his or her effort in order to perform a single repetition for an exercise, whereas 0% RAM maximum would indicate there's absolutely no effort exerted whatsoever. Using this model requires several inputs. First one is being age, which will be listing user profile. Second is test weight, which would be initialized by the user before the evaluation to get the recommended weight. And lastly, we would require connection to several sensors, heart rate sensor as well as accelerometer, using Bluetooth connection. And the assessment is very easy. Simply perform 15 repetitions of the exercise. And to further visualize this, once the user has initialized the weight, for example, 10 pounds, SuperFit will determine whether his effort or her effort has met the requirement for 50% RAM max. If the weight is too light, SuperFit will recommend a heavier weight, for example, 15 pounds. And if it's too heavy, we'll go back down a little bit by 2.5 pounds. So as a result, the user will be lifting 12.5 pounds. And finally, we can recommend a weight to the user depending on his or her goal, as well as using a mathematical model.
Thanks, Shu. Now I would like to introduce about the code block diagram of our app. We separate the code into 3 layers. On top of that is the user interface. And the service layer in the middle provides the major functions for SuperFit. For example, the weight calculation helps us to recommend the appropriate weight for the user. And the motion analysis ensures that the user is doing the right postures during the assessment. Also, the SuperFit will record the daily achievements in the database for the users to trace back their progress. Following, Shu will do the demo for how the SuperFit will work.
So what you see on the screen is the homepage of SuperFit. To set up user profile, just simply have a choice of setting up name, blah, blah, blah. And also to set up the connection to the Bluetooth with sensors, simply tap the Bluetooth icon, and then we can confirm that. So for this particular demo, I'll be demonstrating a exercise called dumbbell bicep curl as illustrated in the picture here. And in the evaluation page, in the middle, there's a red bubble indicating number of repetitions during the evaluation for the exercise. And underneath that red bubble, you can see the live measurements on heart rate as well as movement angle. Lastly, I can initialize the weight by choosing appropriate weight that I should start off for the evaluation. In this instance, I'll be lifting 2-pound dumbbell.
Well, for the procedure of the movement detection, we keep track of the previous data sampled by accelerometer, and we combine it with the current data. We can determine the direction of the movement, and also we can know when the accelerometer entering or leave out the available zone. Okay, well, should try to fill one. Well, the SuperFit will detect whether this repetition is a valid one or a failed one.
you can see that the heart rate is quite stable. It's quite stable right now. And the reason is obvious, because 2 pounds is way too light for Shu to finish this assessment. Okay, the result of the assessment is failed. So we recommend a higher weight for Shu to finish this assessment. Oh, look at those big guns. Shu, do you want to give it a go with the 25 pounds?
Oh, yeah, I can't wait.
Okay, input 25 pounds. Are you ready? Continue.
Okay, I will do the movement detection simultaneously. The assumption is at least that starting at any positions of movement, the accelerometer is in a state of equilibrium. Once in the state of equilibrium, we know that the values output from the accelerometer at the 3 axes are actually the projection of the gravity force. Then we can use the triangles of forces to determine the angles between the upper surface of accelerometer and the Earth's horizontal plane. We can use either the arcsine or arctangent relationship to do this job. This figure shows these 2 functions. As for the arcsine, we can find that the red line is arcsine function. We can find that it has a quite sharp slope, which means that if there's any noise or slight tilt, the result would be hugely affected. After lots of experiments, SuperFit chose to use arctangent to improve the performance.
Okay, well, so now we can see that Shu's heart rate is a little bit, Shu is becoming much stronger since Spiral 4. So I think he need a heavier weight to finish this assessment, but we don't have time to finish another iteration. So if you guys are interested in it, let's just let us know after the class. So right now, let's just go a step further to the key learnings. So the first thing is what is done right. We successfully made the topic funnier, and we also set clear deadlines with some flexibility, which allows us to test the app before the deadlines. But something went wrong. The initial UI design failed to be realized entirely. Also, we forgot to buy the snacks before the meeting, and every single time. But this has been the past story. For the future work, we will bring more exercises as planned to achieve our final goal, the program recommendation. Also, the brand new user experience is needed for a modern, stylish app. And this is SuperFit. Thank you for listening.
So just a couple, 2 comments for the audience. You're wearing a heart rate
Yes.
device right underneath, and I don't think you actually said it. On your wrist is the accelerometer. Is that correct?
Yeah, it's underneath the strap.
Would have been good to say that. I was watching while we were lifting a heavyweight, and it took 4 or 5 reps for it to start counting the actual rep. Is that it just wasn't picking up your rep?
Because it was my poor posture to start off.
Were you
because it was
demonstrating
big.
poor posture, or it just?
Yeah.
Because the difference in the weights, so I had to adjust the posture,
Oh,
the position.
so was that on
You
purpose?
can show that. Yeah, it's on purpose.
Yeah,
Oh, okay.
Yeah, there's a big difference when it's heavier.
Yeah, and this is really casual when it is failed.
Oh, so you just don't lift it up high enough?
Yeah.
And the right angle, you said? The angle of the weight itself?
Yeah.
I understood that you wanted to pick a weight that enabled you to measure the 50% RM. If that happened, does this app give you a recommendation, or it doesn't do that yet? I couldn't quite tell by your future work.
Well, it will.
It does.
Yeah,
Because
it does.
for
It
So
does.
it looked like that was in your future work to give a recommendation.
Yes.
more options to
Well,
select from.
other recommendations.
Yeah.
Yeah.
Okay, I understand. Any other questions? We're going to have to move quickly. Sure. Good questions? Great, thank you.